Dear students, let us begin the chapter polymer. This is your unit 15. So as the term polymer, it means that poly means many and mer means units or parts. So when small units join together, many small units join together to form a long chain compound, then such compounds are called polymers. How we define polymers? Polymers are very high molecular mass. Please check. The molecular mass should not be less than 1000 approximately, and it may be beyond 1 million. Okay, 10 to the power 7, 10 to the power 6 is 1 million, so it is more than that. So polymers are very high molecular mass substances, each molecule of which consists of a very large number of simple repeating structural units joined together through covalent bonds in a regular fashion. So usually the substances which join together to form a long chain, they normally maintain a regular pattern to form the polymer. Now there are a few definitions which you need to know. Monomers. As you know, the term mono means one and mers means parts. So that means one part. The simple and reactive molecules from which the repeating structural units are derived are called monomers. In other words, the substance which joins together to form the polymeric chain are known as or is known as monomer. Now what is the process? Polymerization. The process by which simple molecules, that is the monomers, are converted to a polymer is called polymerization. So polymerization is nothing but a process. All polymers are macromolecules. Macro means large. So all polymers are very large molecules, but all macromolecules are not polymers. Okay, so for example, as you know, hemoglobin, chlorophyll, they are macromolecules, but they are not formed by repetitive units of simple monomers. So they are not polymers, they are macromolecules. But polymers, they are all macromolecules formed by simple small repetitive units. A polymer must have hundreds and thousands of repetitive units, but a macromolecule may or may not contain repetitive structural units. Now let us move to classification of polymers. Polymers can be classified in various ways. The first way of classification is depending on its source. Okay. Now those polymers we are obtained in nature, they are called natural polymers. Some are semi-synthetic, meaning you get the polymer from nature, but they are not suitable for use. So we do some chemical treatment and make them suitable for use. Such polymers are called semi-synthetic. And by synthetic, you mean purely man-made. Okay, they are not obtained from nature, like polythene, then Teflon. These are all synthetic polymers. Vulcanized rubber is a semi-synthetic polymer, and starch, protein, they are natural polymers. So that is the first way of classification. Second way of classification is based on their structure. As you know, each polymer is made up of long chain of small repetitive units. Now if the chains are linearly arranged, one chain is placed next to the other like this, okay, then this kind of structure is called linear structure. It may happen that in some of the polymers there are some branches. Alright, there are some branches, so they are called branched polymers. And those polymers where the two layers are linked together, joined, okay, they are joined. The difference between branch and cross-linked is in branch they are just small parts, but cross-linked means two layers are linked together. Such polymers are called cross-linked polymers. When two layers are connected to one another, then they are called cross-linked polymers. You can see the diagram here. Look for examples, okay, from the textbook. Based on mode of polymerization. So what type of chemical reaction takes place during the formation of a polymer, that is called based on that, we have classified them. One is called addition polymer, another is called condensation polymer. In addition polymerization, the monomers are strictly unsaturated hydrocarbons and they undergo addition reactions. It is not necessarily always they have to be hydrocarbons, they may be any unsaturated compound. And in condensation polymerization, they are formed usually by loss of simple molecules such as water, ammonia, alcohol, etc. And usually for them, the monomers have two functional groups, so we call them bifunctional. We shall be discussing them in detail. Now, another way of classification is based on molecular forces. That means what kind of force is operative in the monomers. One is called elastomer. The elastomers have a spring-like structure, as you have seen the spring in the ball pen. That means if you stretch them, they get D-shaped, but if you release the shape, they come back to their original shape. If you release the force, you may be pushing them, they get D-shaped, and again if you release the pressure, they attain their original shape. So it is just like elastics. So the force of attraction in elastomers is very less. So they have weakest kind of interaction. Then comes fibers. In fibers, usually the force of attraction is hydrogen bonding and the attraction is stronger than elastomers. Next comes thermoplastic and thermosetting plastics. Thermoplastics, as you know, you must have seen there are some people who come home to collect your old plastic containers, whatever leftover plastics, and even from garbage they collect. Now, what do they do with that plastic? Those plastics can be recycled, okay, because on heating they change their shape, they melt and they can be reshaped. Such plastics are called thermoplastics. But there are certain plastics, if you heat them, they melt, but you cannot use them any further. They are called thermosetting plastics. I give you the example, the handle of a pressure cooker, the switchboards, they are all thermosetting plastics. Now I request you to make a comparative study of thermoplastic and thermosetting plastics, which usually is asked in the board exam. You will find enough points in your textbook. Then the last way of classification is what are the different types of monomers present in the polymer. If only one repetitive unit is forming the polymer, then such polymers are called homopolymers. When in the polymer, if we have more than one type of monomeric units, such polymers are called copolymers. Please take care, they are not called heteropolymers, they are called copolymers. So here I have given some work, you can see. Please write down the definitions of each category with example by referring to your textbook. You may find one particular molecule may be present, maybe an example in various categories. So please make a comparative study of addition polymerization and condensation polymerization, that means this one, and thermoplastic and thermosetting plastic, as I said already. Now let's come to the first category of, that means we are now taking up this discussion based on their mode of polymerization. So we are taking example of addition polymers. Okay. So addition polymers, as I said already, they are formed by unsaturated compounds. So this addition polymerization is also called chain growth polymerization. Here monomers are unsaturated, that means they are alkenes or alkynes. Molecules of the monomers add together on a large scale to form a polymer. This type of polymerization is called chain growth because, you need to know this, questions may come, because it takes place in steps leading to increase the chain length. It occurs in stages, and during each step of reaction, you may be ending up with a carbocation or a carbanion or a free radical. That means after each step of addition, you'll be left with a reactive intermediate, which may be a carbocation, which may be a carbanion, or which may be a free radical. That means you cannot stop the reaction whenever you want. That's why this is called chain growth. The chain keeps on increasing. We shall be doing the mechanism for this. The reaction usually takes place through free radical and usually requires an initiator. As you know, in free radical mechanism, there are 3 steps: chain initiation, chain propagation, and chain termination. So in the chain initiation step, we need something which will start off the reaction by forming a free radical, and that step is called, those substances are called initiators. So let us take the example. To begin with, we have polythene, which is a well-known polymer, as we all know, and without polythene nowadays our life seems to be very difficult. Now if you look around in your surroundings, you see we are almost leading in the world of polymers. Right from you wake up till you go to bed, so many polymeric gadgets we are using, right? Your toothbrush, the bucket, the mugs, the cooking utensils, the mobile cover, so many things, enormous, the water supply pipe, the comb, okay, the socks you are wearing, nylon, these are all polymers. So here, as the name suggests, polythene, you can understand it's a polymer of ethene. Ethene is CH2 double bond CH2. Now during addition reaction, we all know the pi bond breaks. Only the pi bond breaks, not the sigma bond. So the double bond turns to single. And when the pi bond breaks, each of the carbons, they have one hand free, one valency free. So with that free hand, it can get connected to the neighboring CH2 molecules, I mean ethene molecule. So that's how they keep on adding to each other, and the product which we get is called polythene. Now one thing you have to take care here, when you write a polymeric structure, you write, and the repetitive units we have to put within bracket, and we write n here. But when you put the bracket, you should take care that these lines, these bonds are being cut by the bracket. That's how we show polymers. If you don't cut the bracket, then they don't indicate polymers. That care should be taken. And one more thing, let me tell you, the polymers are named by their common name mostly, not by their IUPAC name much. Alright. Then let us try to understand there are 2 types of polythene. One is called low density polythene. In short, we call them LDP. Another is called high density polythene. So you can see it has been asked in EMBO's exam 2020. In CH2, n number of CH2 when gives you polythene, but look at the reaction condition. This is the most important thing here. The initiator out here is either oxygen or any of the peroxides. Temperature is 350 to 570. You can see here is a difference of almost 200 degrees, the range. And very, very high pressure, 1000 to 2000 atmosphere, not a matter of joke to achieve. Okay. When you maintain such drastic conditions and you get polythene, such polythenes are called low density polythene. Why are they called low density polythene? We'll come to that later. Then comes high density polythene. You can see in high density polythene, the reaction is done under milder conditions. You can see the temperature range is very small, 333 to 343. That means a difference of around 10 degrees. The pressure is also low, 6 to 7 atmosphere compared to 1000 to 2000 atmosphere. And a special catalyst is used here, that is called Ziegler-Natta catalyst. The formula of Ziegler-Natta catalyst has been given here. You can have a look. It's triethyl aluminium and titanium tetrachloride combination known as Ziegler-Natta catalyst. In this way, when you make the polythene, it is called high density. Now, what is the structural difference between low density and high density? What is density? You know, density is mass per unit volume. Now you can have a look here. I have taken almost 2 equal volumes. Alright. And you can see in LDP, the branches are the chains are little far away arranged, and because they have some branches here. Because when you prepare them under drastic condition, they don't get chance to arrange themselves in proper order. Whereas in HDP, each chain, they arrange themselves in a very compact manner. So as a result, number of chains per unit volume becomes more. And we know density is mass by volume. Now since number of chains are more, mass has to be more. Here number of chains are less, mass will be less. So when mass will be less, Density also will be less because we have taken same volume. So density is low here and density is high here. So that's why we call them low density and high density polythene. So this part is written which I have explained just now. I request you to make a comparative study of this high density and low density polythene as well. Try to make at least 5 points so that if it is asked for 2 marks, even if you forget 1 point, it's okay because you'll have 5 points now. Now, as I said, in these reactions, there are 3 steps: chain initiation, chain propagation, and chain termination. So you have seen that during this polythene formation, you need a peroxide as an initiator. So here we have taken benzoyl peroxide. Now what is benzoyl peroxide? It is benzene ring, C double bond O, then this OO linkage is called peroxide linkage. Then again the CO C6H5 is repeated. So you can see this is very much a symmetrical molecule. And this bond, this peroxide linkage may undergo homolytic cleavage. And as you know, when we write homolytic cleavage, we put a fish hook arrow, half arrow. So one of the electrons go to this oxygen, another electron go to this oxygen. So thereby forming 2 benzoyl free radicals. 2 benzoyl free radicals. There is a dot here which may not be visible. Now this benzoyl free radical is not very stable and it immediately loses a molecule of carbon dioxide to form phenyl free radical. There is a dot here too. So our initiator is ready now with a free radical. So this initiator will now attack an ethene molecule homolytically, and the pi bond will break homolytically and get attached to the phenyl free radical, and that's how one of the ethene free radical is generated. So step 1 is done, chain initiation. Now once this chain initiator is ready, you can see the chain propagation step. Now this one which has formed here will attack another ethene homolytically, the pi bond will break, and at the end of this step you will be again left with another free radical. You will be left with another free radical. I hope you can see the figure here. This free radical. How do you get this free radical? This bond which is breaking here forming a free radical, this radical is combining with this one forming a bond, and this one remains as a free radical. So this way when I put 2 arrows here means there is number of steps taking place in the similar fashion, and that's how we have at the end C6H5. This is not a repetitive unit and this whole unit is repeated, CH2 unit n times, and at the end we have CH2 with the free radical. So this way each chain we may not be having same length. This number n may vary from chain to chain. And lastly we have to stop the reaction by chain termination method. So if we take two chains where n may be same, may be different, they couple together, two free radicals couple together and form polythene. And here in this step you may notice there is no more free radical left. So that's how the reaction will come to an halt. So this is the mechanism for free radical polymerization, for addition polymerization. There are some more examples which you need to know with their short forms under addition polymers. These are number 1, polytetrafluoroethylene, in short PTFE, known as Teflon. And you know Teflon is used as non-stick coating in our cooking utensils and many other heating gadgets such as electric iron and all. So what is tetrafluoroethylene? Ethylene is CH2CH2. Ethene is the IUPAC name of ethylene. So instead of hydrogens you have fluorine here. So tetrafluoroethylene in presence of catalyst and high pressure undergo similar polymerization and they give you Teflon. Though you know this non-stick cookwares are very handy in the kitchen, but too much of use and bad quality non-stick cookwares if you use, they are causing cancer. Very toxic. They are not good to use. Nowadays you know that people are suffering more due to cancer and various other diseases. That is mainly because of so much of chemical in use. Earlier days people used to have their food and cooking used to be done on metals. which were not harmful. In fact, they were healthy. So it is not advisable to use non-stick cookware, especially the cheaper ones. Okay. Then we have another one, polyacrylonitrile. Okay, and its short form is PEN. Polyacrylonitrile, PEN, also called Orlon or acrylon. It looks like wool. Okay, it is used in making carpets and all. So what is nitrile, acrylonitrile? It is ethene itself. Just replace one of the hydrogens of ethene by cyanide group. Then what we get is acrylonitrile. When acrylonitrile undergo polymerization, it forms polyacrylonitrile. I request you to look for their properties in the textbook. These are also a kind of homopolymer because you have seen we have not used different types of monomers here. Thank you.